Now we will consider the linear cycle problem, and to understand the linear cycle problem we have to consider a map of a city in which there are 12 islands and 17 bridges. And if we convert this map into a graph, then we will consider the 12 vertices, and these vertices, they represent the 12 islands, and the 17 edges, and the 17 edges, they will represent the number of bridges in that island. So when the map was transformed into a graph, then we can see that the bridge obsession problem will now convert into the Eulerian cycle problem, and that problem was solved by the Euler, and after solving that problem he has contributed to the applications, thousands of applications in the various fields of science and engineering. So we can see here in this diagram that there are 12 islands starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And there are 17 bridges that interconnect with each other, different islands. And now again the target is to define the Eulerian cycle problem, in which if one tourist start from the island number 1, so it should visit the bridge only once, and then after visiting the bridge only one time and all the bridges he has to visit one time, then he has to end up to the island number 1 again. That is the starting point. So we can also represent that map and transform that map into graph form. So these vertices, they show the island's location as we have seen in the previous diagram, and these vertices are numbering are the same as in the previous diagram, and they represent the number of islands. And the lines that are present in between the two vertices, they represent the edges, and they, if we compare with the map, they represent the number of bridges that are present in between the vertices. So the target is that we have to start from the island number 1. We have to visit the bridge, now here it is vertex, one time, and again we have to end up at the island number 1. So the path that we should follow in the sense is that the correct path will be, if we start from the island number 1 and then we visit this bridge and reach to island number 2, then the island number 3, then 4, 5, 6, from 6 to again island number 3, then 7, then 2, from 2 to 9, 9 to island number 11, from 11 to island number 8, then to 7, then to 12, from 12 to 11, then 11 to 10, 9, and then we will reach to the starting position island number 1. So we can see here that in this systematic movement of the within the islands, we have noticed that we have used one bridge only once, and after using the bridge once, we again end up at the island number 1 from where we have started the tour. So this type of graph and this type of problem is called the Eulerian cycle problem. So the Eulerian cycle problem, and the problem statement is we have to find a cycle in a graph that visits every edge exactly once, and we have seen that in the previous that we have used the every edge exactly once. So the input of this algorithm will be a graph G, and what we will get the output, a cyclic in G graph that visits every edge exactly once. And we have seen in the previous slide that we have visited each of the edges exactly once, and we again end up at the island that from where the tour was started.